We had the last session, that's the mold design basics and principles. May I please request Mr. Subhash Araksali to join us. He's taking over for this last session.
Very good evening, ladies and gentlemen. So I am given the last session so that I can wind up faster. And most of the subject points that I am going to cover are the gist of all the sessions that have been covered so far. This is mainly on tooling aspect, but these are only basics as you rightly hear from that one. So I welcome all the people for this International Tooling Summit, and this is the topic chosen by me, Mold Design Basics and Principles. So these are some of the key business challenges we all have. So I won't read more into the details of this one because these challenges are almost known to each and every one of us on that. So I will go to the actual points where we have to see. So this is in general the design and development cycle, where the part comes from the customer, then it is to be given back to the customer. It comes into the molding shop or mold manufacturing or development shop in the form of digital input, but it goes out in physical format. So from digital to physical. So there is a lot of transformation in this. So there are certain headings which are covered here, where you can see most of the upper half of that one is all related to the customer, and the lower part is related to the design to manufacturing of that one. And that. So you can see here, I will go more into the details here where the tooling people are concerned. Leaving apart the commercial part of it, our product starts from here, where the final 2D drawing and this thing comes on this one. You see here there is a requirement of employer where there is a shortage of skilled candidates, and there is a educated youth which are employed with less industry readiness. So there is a gap between these employer requirement and the educated youth, which needs to be bridged with the knowledge focus and refining the skills with professional training, which is not being taught in any of the educational institutes so far. Now here I have tried to show what if the educated youth come into the industry and they want to be made ready without going back to this thing. So I have shown the pictorial representation of a mold, when they have come to a molding shop, what does it look like? So it is written there in the expressive data of a mold trial. So this is what is the fact. So we know, all of us, that wherever we stay, there are big apartments with hundreds or 200s of flats, where we get one as a sample flat. So this is like a sample of a mold, where before it goes to the molding shop, what are all the prime requisites which are required, that need to be given to the molder when it goes from manufacturing unit to the molding or trial unit on that. And this is where I have given, without numbering, today we see in majority of the companies that the people do not make the mold assembly drawings where the nature of parts, number of parts, standard parts which have to be bought, materials from which the parts have to be made are not being indicated. Why it is not being done? In my last 12 years of experience around Pune or around, I have seen that there are two departments. One is the mold maker and the one is the mold design department. Mold design departments most probably are equipped with the people who are below 30s, who are only working on the basics of everything which the customer wants, whereas they are not industry ready and they do not know much about the activities of that one. So here I have tried to show them in the pictorial format, taking a section of a 3D model. If a mold is cut, how many parts are looking here, and each part is named here with the general material that is being made. So these are different sections where each and every item that we read into the 3D model tree can be shown. Then next comes this is the left side. What you see is the part drawing which comes. Why it is going back? Okay. Why it's going back? वो रुकता नहीं है. So here I have shown on the left side the part drawing, and the right side is the mold drawing. What is that? So this is the dimension chart for tooling where each and every part dimension is numbered in that one, and this is a chart which is to be made before the part is taken for mold manufacturing or mold designing on that one. So some of the part dimensions are having unilateral tolerances which have to be converted in this chart into bilateral tolerances. Once the bilateral tolerance is being made on this chart, the 3D model has to be updated to the dimension which are required by the customer from bilateral to unilateral to bilateral. And you can see in the black color, it is written as position number in the mold. So each dimension of the customer, which the customer is going to check when it reaches his shop in the inspection, the part dimensions are going to be checked. So if the part is to be checked, then you have to see that the dimensions are being reflected in the mold as well. So here what we do here, you can see in the yellow color, it is the target dimension. Then the pink color column, it shows the actual dimension which is seen on the drawing on that part number, position number 31, which is shown in the black column. So every part number which is shown in the mold assembly drawing will have these dimensions. 7.99 what is shown here will be inside in that one, which will be marked as the serial number 1 is the dimension number of the part in the part drawing of the customer. The same will go in the 31 also, and the actual dimension is measured in the, you can see in the blue color here, there the actual dimension of the cavity is written here on that. So he can validate that the customer's dimensions are taken right from the input till the part is being made. In the previous presentation, he rightly said that all the things which have to be covered for molding, if you want a molded part to be accurate, it has to be starting from the design input itself till the mold comes to the trial end. So this shows in short, I have taken only 3 dimensions only for demonstrating the activity of that one. So this is the sample molded shot which can be done before the mold is being actually made. So this is like an electrode forming. So wherever the cavity is having a area, you can fill it and get this thing. So this is sample. So one you saw the sample of the mold, and this you saw the sample of the shot. Today this will not be available unless the part is being molded. So this is a molded shot. So if you go to any shop, the people show you the part, not the shot. But the mold makers must always see the shot, not the part. Because when you go to the MD doctor for diagnosis, he actually touches our hand and finds out how is the pulse. So this shows the pulse of the molded part when you see. Actually, here I have shown how the part actually is being filled right from top there. What should be the dimension of that one? It should be 1 millimeter less than the sprue inlet, that is a plastic inlet into the mold should be 1 millimeter less than the 1 millimeter more than the actually nozzle entry diameter there. Then it is the sprue comes there down. If it is a cold sprue mold, then you have to make a vent there. You can see there sprue vent is written. Then it goes ahead. Then the runner vent is made. The air is taken out. Then when it goes inside into the component, you can see on the right side bottom, there is a cavity vent. So air which is filled into the sprue, runner and cavity has to be taken before the plastic enters into the cavity part. So if we say that when the fate of the part is left for the mold maker, but he will not be able to do anything in the mold other than filling the part with the plastic only. So this you can see here, to even identify which gate is made by what. You can see here, the gate drawing size is given 0.9. If there is a multi-cavity mold, each of the cavity dimension is measured and also noted. Whereas the gate diameters are not noted, they are like the windows where the plastic enters into the mold. So here the gate diameters also have to be measured and they have to be indicated. You can see here gate sizes actual are written. So how much should be the tolerance of this is based on the accuracy of the person who makes the mold. So the shorter the accuracy band, then better is the mold. So you can see here this page is given along with the mold first part what I showed to the molder before the part is being taken out. So he comes to know how is the runner of that, where are the vents made, then how is the mold looking, what is the area of the clamping, what is the size of the mold. All these are given in the pictorial format where he can easily note. So now here I have taken one of the example of a mold where these are the the part which is having a red color is the outer surface of that and green is the inner surface of that one. When you see the face of the mold, you can see here that there is a mark which shows the identification for orienting the core or the cavity block into the mold housing. Then what is the material of the part is written. What is the hardness of the part is written. It is engraved. So these have to be documented and engraved on that one so that customer does not have to ask anything to the mold maker. So he should get the comfort of seeing this all beforehand only here. Then part number is given. Each of the cavity number is given outside the cavity. Inside the cavity also numbering is done, but that goes to the customer. But when it comes to the maintenance of the mold for that one, which cavity is located where, no, it is unless otherwise you note it outside or indicate it outside, no, it will not be possible for the mold maker to know. Because cavity numbers are marked on one of the halves of the mold, either on the core side or on the cavity side. Here if you see, the cavity number is marked both on the, so you can see this is the mold injection half, this is the fixed half, there is a cavity half. So now next is the core half. Here also you have the cavity numbers written. Whatever is written on the fixed half or in the injection half is also written on the ejection half also, so that it is easier for the mold maker to know what exactly is done. Even here we have the number for the runner also, where the cavity number is written outside the cavity. Similarly, gate closer to that one is also indicated as the gate number of that one. So this is a typical family mold, where if a family mold is made, all the three cavities will be having different volumes. So how to see that one, that these have to be balanced? As rightly said in the earlier session about scientific molding, you need to go to the software for flow analysis to find out how to balance this. But the best way here is to make a separate, each part should be able to mold on that. So you have got different mechanisms of round sections there like bushes which can be rotated so that only one part can be molded at a time. You have the choice of molding one at a time, or you can mold all the three at a time also. Then when there is one part molded at one time, then there is a nameplate where there is an indicator in red color which shows which part is getting molded inside. So this is an indication for knowing. There is an indexable screw there where it has to be taken out and then put depending on the cavity which is going to run. So this is the nameplate of that. You can see the red color one which shows which part is being molded. This is for the shortest, this is taken out as a case study. I have made it in a, you can see it is in 2016 where I was visiting a customer, is a well-known customer is in Pune, where the designers which are supposed to make, he has made on the right side the old one which is called 55 millimeter is the length of the runner, length of the sprue. So sprues are being the waste, you know, they have to be made to the minimum height possible so that you can limit the cold sprue wastage on that. So on the left side is the design which I have given, made by the same fellow, where he said that this is not possible because the simplest way for a designer is to make the right side one. So most of the designers, if you see here available, they will always make the right side designs where the owner is compelled to put his money to spend for the lesser skill what he has used in making the mold designs on that.
So this is how today's designers are there. So they have to be updated
on regular basis.
So this is a typical, you can see these are all global branded, hot runners are there.
So I have made this as this thing example is,
The designers must know what is the contact area required. This is in one shop on one day. At the same time, two different global brands were available with both having the problem.
the left side is one which is only a cold screw and the right one was this is only cold drop and that was a manifold actually. You can see there, no, 32 millimeter and 50 millimeter, that is a taper. So this is the contact area which the people had. On the left side, it is a simpler one. Then it was having 7.5 millimeter on that. So whatever heat, the hot screws are given so that we can reduce the length of the cold screw, that is the waste. So in trying to do that one, with the owner says that you go for hot screw. The person who puts this hot screw doesn't know about the concept of the hot screw only and that. So none of the, irrespective of the brand, the contact area in a mold for any hot screw should not be exceeding more than 3 millimeter. Whereas it is, you can see it is 10 times on the right side and in the left side it is around 2.5 times on that one. Where actually the basic crux lies here only on that one. So here what happens, I have seen, the people blame the brands which are global brands. So then they start using the local brands. So in local brands the people do not know again none of these ones. So how these designs are made by the global brands also. So these are actually now sourced inside in India by the Indian designers. So Indian designers most probably are not equipped with all these tactics or the concepts of hot screw concepts. So that is the reason why such things happen in India. So these are some of the sketches which are made. You can see here. So in the first sketch you can see on the left side there the runner is made on both the house, but the gate is used on one half only. But the other half plastic which comes there, it bangs there, you can see there in the arrows, and it does not enter or it hinders there. So what is the best practice is to, you can see on the right side there, closer to the gate on the fixed half, you have to make on the other half also the plastic entering there so that it helps to facilitate the filling part on that one, which is not normally made because this is overlooked by the designer. And once the designer overlooks in an industry, nobody else will be there to stop that error, no matter how good the company is. So similarly, to quote that an example, I have given on the left side bottom, you can see there is a 3-plate mold with a center gate where the center gate where it is round, we make a round electrode there. So there also on the similar grounds of the right side top, if I make the same half round here, you can see here, we have made half of the gate. It is difficult, that's why this is not made. There it is easy, that's why it is made. These are silly points, but these are very essential for a mold designer to know. So here you can see, physically it is balanced, but if you actually run, this is like a road where if we run along the green color with a motorbike, 2 persons if they run, the person on the green, he will reach faster. But the person with the red, it is having a diminished flow, which holds good even for us when we are on the vehicle. Same happens in case of plastics also. To avoid this point, what we have to do is, you have to make a combination of this one. So every part, as the principle, the last point of filling should be same in all the cavities, regardless of the size of that. That's why we have to measure the cavities, we have to measure the gates, and here we have to make the filling also same. So these are all the very silly points which are taken. You can see the gate there. These are the gates made on 3D models, on 3D molds. Why these are going to be made, maybe anybody who is interested in know why this design is made like that, I will answer this one personally, but I will not explain this one. But in the next slide it is shown there also. You can see here, in a thin line green, I have shown where it should have been made. But if I give the pencil and paper to the same designer, he will never make the way he made in 3D model. But he makes that one when he is making it. When he makes on the paper, he makes like this way. Yeah, this finish.
So this is the last, most probably. You can see on everybody makes the lifting, the opening of the plates, they make in the corner the flats there. But the fulcrum, what they use there for, is not going to help here on that one. But what they use is the crowbar or the screwdriver. So you have to make a slot which is equal to the screwdriver shape. What is shown on the right side there on that. These are very silly, but these are very essential on that one. Today nobody objects in a tool room because it is already made. In a product drawing you can see here, there are ribs which are shown, but radius making for the ribs for the product designer is difficult, that's why these are left off. So till the end you find this one all sharp, which are against the principle of mold flow analysis on that one. So wherever the plastic wants to flow, it should have a radius. So here this is just a simpler graph to show that you have to see, to reduce the cost of that one, you have to take all the activities to be seen or reviewed at the design stage only. So here is the quote saying that knowing, I know the mold making, but I don't follow that. It is like not knowing only. So this is the significance of a good mold. So here is a slide which is given last time. You can see this is also a International Tooling Summit of 2019. The reason why I have taken this one is, you can see at the bottom, the person who is on the right side there is you can say he is the Canadian chairman of Tooling Association of Canada. What he said is, every tool room which they have is taken so like a temple. So here now we have to see, temple means you have to see the hygiene of that one and discipline of that one too. So I will not play the video. So thank you, and we will meet again. So thanks for International Tagma Summit for giving me this occasion to wander faster and give me the last session. Thank you once again.
Thank you so much, sir. Sir, please remain on stage with us. May I please request Mr. Bhaskar Kanchan to join us, our director. May I please request him to hand over a token of appreciation to sir. Ladies and gentlemen, please put your hands together. The last session of ITS 2025.